Alright, hello and welcome. We're going to run over a quick video blog here from techworldwiki.com. I'm your host, @NetWookie, and we're going to talk today about installing the HP van SDN controller in a Docker container and get an environment up and running in 15 minutes. We're going to have a Docker host with 2 Docker containers that are ready for you to pull. You're going to need an external source to generate some OpenFlow traffic. That will either be a Mininet server or an OpenFlow capable switch. We're going to start with just a straight up installation of Ubuntu Mate. Just about any Ubuntu workstation should work for this. Red Hat also works, so pick your flavor, but if you want it to work and guaranteed, just follow along with what we got going on today. So Ubuntu Mate, we're going to go ahead and log into it and get our environment set up. I have a little cheat sheet file here that I made with some of the commands. Some of the Docker command line stuff could be very long, and there's quite a few options we'll see a little bit later, so I don't want to have to type everything in. I'm basically not that energetic today, so I'm going to have stuff that I can just copy and paste on the command line for us. So the first thing to do is let's get a Docker server built. So is this a very hard process? No. I'll show you here that Docker itself is not currently running on this Ubuntu workstation. So we'll just say sudo docker and see if Docker is even loaded. And you can see that the command's not found. So 2 commands is all it takes to get a Docker server up and running. We're going to just do an update to the apt-get utility, and we'll make sure it's got all the latest and greatest pointers to everything. This doesn't take too long, and it should rattle right on through. And then once we do the apt-get update, we're actually just going to go ahead and set up the Docker server. It's one command to make this happen. It's very simple. It's sudo apt-get install docker.io. But Linux is Linux, and you must type exactly what you mean. You'll see here I have a capital S in front of the word sudo, and it's not going to like that at all. So capitalization, punctuation is so critical when you're dealing with the Linux command line. You got to make sure you have it exactly the way it needs to be. So we'll just go back here and make this a small s on the sudo command, and away it goes. Answer yes, and we'll go out and find the Docker IO software and get it installed. So the sudo command lets you become privileged, gives you a privilege level inside Ubuntu, so you can't like su to root like you do in other Linux distros. So sudo is necessary to be an elevated command. So let's go back and test this again. So we'll say sudo docker and list the processes and see. There's nothing running, but you do see the headers for the processes, the status, the ports, when it was created, stuff like that. So that is a good indication that Docker is installed and running, and we have our Docker server. So we need to go get a couple of Docker containers. So normally you would build a van SDN controller, and it would take you quite a few things to do to get that server up and going. But with Docker, the SDN controller already being inside a Docker container, you can simply go out and issue the Docker pull command. So we'll say Docker pull. My handle at dockerhub.com is XOD442. And the SDN controller is under van 2_5. That's the latest release of the HP van SDN controller. So normally you'd have to go through a lot of process of, well, it's not really a lot, but there's quite a few things you would have to do to get the actual image up and running. And what this does, it simply lets you go out and pull that whole thing in its entirety, brings it down, and within one command later we can enter on the command line a Docker run command, and the container can be up and running. So Docker just pulls down these layers that are unique to the container. So this isn't really a virtual machine that we're pulling down. It's just basically a box with the stuff necessary to run whatever's inside that box, the stuff that's different from the host operating system. And as you change things in the box, it simply copies them out of the host and adds them to the container. So that way this container has portability. So once I get an application built in a container, I can actually put it out on Docker Hub, and the rest of the world can pull it with one command and start it with a second command. This makes sharing applications, linking applications, and porting applications very simple and very easy. So this is going to take a little bit of time to make this happen, but it's depending on your bandwidth, it could be 5 to 10 minutes. But we're going to actually finish pulling these layers down, and once we get all the layers down, we're going to take a look at what's really happening. So what we're getting is a Docker image. Once we have that image, we're going to actually run that image inside a Docker container. So it's not a really hard process, but on the Docker command line, there are a lot of flags and a lot of options that you can use, and I would suggest if you're new to Docker, either going out and doing some research or check out our blog post at techworldwiki.com, and you'll find a whole bunch of information about Docker and Docker containers and what you can do with them. So it should be pretty close here. You can see this process hasn't really taken a whole lot of time, but then we're pulling down a complete container, or a complete image rather. And what will happen is if we pull down another similar image, we'll only pull down those things that are different. So it'll be a lot quicker next time. So now what we're going to do here is we're going to go ahead and fire up this container and see if we can get the container to actually launch. So I'm going to put the Docker run command here on the command line, and you can see we're exposing port 8443, that's secure HTTPS, and 6633, which is for OpenFlow. And if we go ahead and look at the processes that are running again, you can see there's an actual container ID with the image of van_25 latest. It's up and running. It's been up for about 8 seconds. So you can see here that this little command will tell you a lot of information about the status of that container. Sometimes we'll see a container pop up and then shut right off. So that would indicate there's some sort of a problem with the way that container is built, the way the container is running. Again, I highly recommend picking up some Docker chops if you can. But for this example, we really don't need those. So what we're going to do now is I want to show you that we have here our Docker containers up and running. We're going to launch a web browser here, and we're going to try to actually browse into that specific SDN controller. But before we do that, I think I'm going to need to find my IP address. And so there's a Docker interface that gets created, and it gets bound to all the interfaces on the host. It's sort of like bridging out to the Ethernet 0 adapters. So we'll address everything on the Docker server by this particular 10.132.0.223 address. So for us, we'll put in the secure HTTP, give it the address of 223 and port 8443, and the URL is sdn/ui to get to the HP van SDN controller. And we'll get the normal Danger Will Robinson stuff, but we'll just go ahead and click on through this, and we'll accept all risks here. Interesting 404 comes up. What's happening is the HP van SDN controller does take some time to become a controller. There's a lot of processes starting up and a lot of things that it has to get in order before it'll let you actually web into it. So we'll give it a spin here, and you'll see here's the login page. We're going to log in with SDN, and the password is Skyline. And those are case sensitive. They're all small case here. And we're just going to go ahead, and this is the most aggravating part of Firefox. But we'll see here that we're inside the HP van SDN controller. And all by itself, it's not really that amazing. It's a great thing. It's an entity on your network, and it's an SDN controller, but it's not really listening to anything. Well, I guess it is listening, but there's nothing talking to it. So what we're going to do here is we're going to go out and get the other half of this DevOps environment. We need to get some sort of a LAMP server that we can actually write some HTML against and some Python against, and tell it to go out and use the APIs of the SDN controller. So we're going through that process now, and I'll spare you the download here, but we'll get to the end of this pretty quick here through the magic of video editing. And now that we have this, we're going to go and say, hey, look at our disk space. Wow, that's really got used up here. I built this on top of an Ansible server, so it's probably lucky we just squeaked this one in. So if we do a Docker images command, we'll see that we now have 2 Docker images. We have the Mac find 5, which is a LAMP server that I built. It's out on my dockerhub.com account, and the van controller. So we're going to run this LAMP server in the foreground with this command. We're going to expose port 80. So now what we want to do is go see if that web server is up and ready for us to use. So if we just put in the same 223 address, but this time just standard HTTP with no extra port numbers, we're going to go and point it to a file that I've preceded in this LAMP server that is an HTML page you can use for a starting page if you want. And it's going to ask for a few things. This is what's your IP address of the SDN controller, and what's the username and password. Well, what I've also built in this LAMP server is the Dave Tucker HP SDN client Python library that's going to really assist you in quickly and rapidly developing applications. So you'll see that I said find nodes here, and there are no nodes to find. That's because there's nothing speaking OpenFlow on the network at this time. So there's nothing to monitor under the OpenFlow monitor. If I look under topology, there's nothing under topology. So great piece of software, but without anything to do OpenFlow with, it's just a pretty piece of software. So what we did, I just fired up another Ubuntu workstation in the background that's running Mininet, and at this moment I'm issuing the ping all command on the Mininet server. So that should have all the hosts start pinging each other, and all the DPIDs start doing their thing and reporting OpenFlow back out to the SDN controller. I've set it up as a remote IP to the Mininet server, and in a minute here we should start seeing some evidence that there are OpenFlow entities out on our network trying to talk to our SDN controller. And you should see that here. If I look under this OpenFlow topology, we should start seeing the DPIDs. Those are the data path identifiers. Those are the big blue blocks that are popping up. That is our Mininet network in the background putting out OpenFlow. So if we look under OpenFlow monitor here, pick any one of the DPIDs, and then we check the flows. We see we have real SDN information. So if we go back to our little test script here and put the password back in of Skyline, we're going to see that we now have nodes. So this is a great thing. It simply went out, used the API, the RESTful API, said, hey, tell me about all your nodes. So now we have the IP address, the MAC address, the vid, the DPID, as well as the port number, so we can start getting some idea of where these hosts live in the OpenFlow network. So that's about all we're going to cover today. And there's plenty more to be discovered out on the blog, techworldwiki.com. Make sure you give that a visit, and make sure to follow me on Twitter @NetWookie. Thanks and have a great day.